This is a training module on the Infineon TC1161 and TC1162 32-bit single-chip microcontroller with TriCore technology. Welcome to the training module on the TC1161 32-bit single-chip microcontroller with TriCore. This module will describe the T1161 and T1162 features, TriCore Architecture and its other functions like CAN, ADC, Fast ADC, and clock management. The Infineon TriCore Architecture combines the best of three worlds, RISC, DSP, and microcontroller together in a single core to offer maximum system performance for embedded real-time applications. The TC1161 is optimized for highly demanding applications where embedded real-time performance and DSP capabilities combine with an extremely fast interrupt response time and where high levels of fault tolerance are needed. The TC1161 is based on the award-winning unified 32-bit TriCore architecture combining RISC, CISC, and DSP functionality in a single chip. The peripherals include a comprehensive and flexible timer unit for pulse width modulation, multi-channel ADCs and serial interfaces with microsecond bus and microlink interface. Together with its 1 megabyte of embedded flash, the TC1161 offers the most cost-effective 32-bit microcontroller solutions for real-time control. The TC1161 is optimized for highly demanding applications where embedded real-time performance and DSP capabilities combine with an extremely fast interrupt response time and highest level of fault tolerance are needed. The TC1161 has two independent on-chip buses, Local Memory Bus LMB and System Peripheral Bus SPB. Both the LMB bus and the SPB bus run at full CPU speed. The maximum CPU speed is 66 MHz. Additionally, two simplified bus interfaces are connected to and controlled by the DMA controller. The DMA bus and the SMIF interface. The LMB bus connects the CPU local resources for data and instruction fetch. The local memory bus interconnects the memory units and functional units such as CPU and PMU. The main target of the LMB bus is to support devices with fast response times, optimized for speed. The SP bus is accessible to the CPU via the LMB bus bridge. The FPI bus interconnects the functional units of the TC1161, such as the DMA and on-chip peripheral components. The FPI bus is designed for quick access of the on-chip functional units and quick transfer of data to some of the units like the PMU, PMI, DMI, and on-chip memories that are used as program or data memory. This table gives features and benefits of device TC1161. The device has a high-performance core with 4-stage pipeline and triple-issue superscalar implementation. It also has a powerful MAC unit which supports a circular buffer, and it has a single precision floating point unit. TriCore is the first combined 32-bit microcontroller DSP architecture optimized for integrated real-time systems. It combines the outstanding characteristics of three different areas: the signal processing of DSP, the real-time of microcontrollers, and RISC processing power. And it permits the implementation of RISC-loaded stored architectures. The instruction set architecture, ISA, supports a global linear 32-bit address space with memory-oriented I/O. The operation of the core is superscalar. It can execute simultaneously up to 3 instructions with up to 4 operations. TriCore maintains a mixed 16-bit and 32-bit instruction set. Instructions with different instruction lengths can be used alongside each other without changing the operation mode. In a TriCore system, multiple sources such as peripherals or external inputs can generate an interrupt signal to the CPU to request for service. The interrupt system also supports the implementation of additional units which are capable of handling interrupt requests. Besides the main CPU, up to 3 additional service providers can be handled with the Interrupt Service Request node, SRN. The actual number of additional service providers implemented in a given device is implementation dependent. Each interrupt or service request from a module connected to a service request node contains a service request control register, SRC. Interrupt arbitration buses connect the SRNs with the interrupt control units of the service providers. These control units handle the interrupt arbitration and communication with the service provider. The interrupt arbitration scheme permits up to 255 sources to be active at one time. The asynchronous-synchronous serial interfaces provide serial communication between the TC1162 and other microcontrollers, microprocessors, or external peripherals. The ASC supports full duplex asynchronous communication and half-duplex synchronous communication. In synchronous mode, data is transmitted or received synchronous to a shift clock, which is generated by the ASC internally. In asynchronous mode, 8-bit or 9-bit data transfer, parity generation, and the number of stop bits can be selected. Parity, framing, and overrun error detection are provided to increase the reliability of data transfers. The MSC interface provides a serial communication link typically used to connect power switches or other peripheral devices. The serial communication link includes a fast synchronous downstream channel and a slow asynchronous upstream channel. The downstream and upstream channels of the MSC module communicate with the external world via 9 I/O lines. 8 output lines are required for the serial communication of the downstream channel. The GPTA provides a set of timer, compare, and capture functions that can be flexibly combined to form signal measurement and signal generation units. They are optimized for tasks typical of electrical motor control applications, but can also be used to generate simple and complex signal waveforms needed in other industrial applications. The ADC module has 16 analog input channels. An analog multiplexer selects the input line for the analog input channels from among 32 analog inputs. Additionally, an external analog multiplexer can be used for analog input extension. External clock control, address decoding, and service request interrupt control are managed outside the ADC module kernel. External trigger conditions are controlled by an external reset request unit. This unit generates the control signals for auto scan control, ASGT, software trigger control, SWOTR, and SWOGT, the event trigger control, ETR and EGT, Q control, QTR and QGT, and timer trigger control, TTR and TGT. The on-chip FADC module of the TC1161 is basically a 2-channel A to D converter with 10-bit resolution that operates by the method of successive approximation. The main FADC functional blocks are the input stage, which contains the differential inputs and the programmable amplifier, the ADD converter, which is responsible for the analog to digital conversion, the data reduction unit, which contains programmable anti-aliasing and data reduction filters, the channel trigger control block, which determines the trigger and gating conditions for the two FADC channels. The channel timers can be independently triggered via the conversion of each FADC channel, and the ADD control block is responsible for the overall FADC functionality. The multi-CAN module contains two independently operating CAN nodes with full CAN functionality that are able to exchange data and remote frames via a gateway function. Transmission and reception of CAN frames is handled in accordance with CAN specification version 2.0b. Each CAN node can receive and transmit standard frames with 11-bit identifiers as well as extended frames with 29-bit identifiers. Both CAN nodes share a common set of message objects. Each message object can be individually allocated to one of the CAN nodes. Besides serving as a storage container for incoming and outgoing frames, message objects can be combined to build gateways between the CAN nodes or to set up a first-in, first-out buffer. The OCDS Level 1 debug support is mainly assigned for real-time software debugging purposes, which have a demand for low-cost standard debugger hardware. The OCDS Level 1 is based on a JTAG interface that is used by the external debug hardware to communicate with the system. The OCDS Level 2 debug support makes it possible to implement program tracing capabilities for enhanced debuggers by extending the OCDS Level 1 debug functionality with an additional 16-bit wide trace output port with trace clock. The microlink interface is a fast synchronous serial interface that allows data exchange between microcontrollers of the 32-bit ADCO microcontroller family without intervention of a CPU or other bus masters. The above figure shows how two microcontrollers are typically connected together via their MLI interface. The MLI operates in both microcontrollers as a bus master on the system bus. The MLI transmitter and MLI receiver communicate with other off-chip MLI receivers and MLI transmitters via a 4-line serial I/O bus. Several I/O lines of these I/O buses are available outside the MLI module kernel as a 4-line output or input bus. The TC1161 clock generation unit, CGU, is shown in this slide. It allows very flexible clock generation. It basically consists of a main oscillator circuit and a phase-locked loop. The phase-locked loop can convert a low-frequency external clock signal from the oscillator circuit to a high-speed internal clock for maximum performance. The clock system must be operational before the TC1161 can function, so it contains special logic to handle power-up and reset operations. Its services are fundamental to the operation of the entire system, so it contains special fail-safe logic.